Welcome back. In front of me I've got a piece of steel plate which I bought from a local scrap dealer. Now what I want to do with it is make a press plate for my for this piece of tube that I'm using to crush my cans. Now the thing with this is I can press on a flat piece of plate, I can press the cans nicely, but I can't get it out. So in order to get it out, I need to a press plate that will have a hole the size of the inner bore of this tube, and that will allow me to press the cans out at the bottom. So what I'm going to do is clean up the outside on the milling machine, and then I'm going to do the cleanup of the entire plate, the two flat surfaces I'll do in the 4-jaw chuck and a lathe. So it's very simple, and the bore will also be done on the lathe, obviously. So it's all simple machining, but yeah, should be entertaining as well. Now this plate is 25 millimeters thick, 180 by 150. So hopefully I should be able to fit it into my 4-jaw. I'll see. The 4-jaw is only rated for up to 160 millimeters, but I think I can stretch additional 20 millimeters out of it in the sketchy setup. Alright, my setup here in the mill is very simple. I've got two 1 to 3 blocks on my milling pallet. I'm just going to add 2 studs that will fit through the middle of the hole. And what I like about these combination machines, to square up your stock is very easy. You use your lathe spindle to square up your stock, and that will always be square with the machine. So what I need to do here is, because of limited travel, I want to make sure that when I place my stock in here, that I'm as close to the cutter as possible on this side, so that when I move to the other side I will have enough travel to be able to machine that side. Should be able to clear the back. Okay, all I need to do is to put one of my parallels here in front, and square up the stock like that, and bolt it down. Now I can just, once I've bolted it down, I can just machine all the way around without needing to change any setup on it or to move the plate in any way. So that's the beauty of a pallet table, is the fact that you've got access around your perimeter, so you can square it up in one setup. I don't know what grade of steel this is, so I'm going to use a cutter that I've busted already. Now what I like about this specific end mills, one of those end mills that I got from, that was sponsored from JLCMC, is the fact that there's uneven spacing between the cutters on the spiral flutes. So what happens is, because of that uneven spacing, like a car tire, it stops any vibration from happening. So the chances of chatter is minimized with these cutters. Now this thing has been chewed up in the bottom because it was milling TH 400, which is a wear plate, and being a wear plate, it grabs the cutter, or the cutter, once a cutter bites into it, and if a cutter doesn't bite into it, it just dulls it. So it's a tricky material to machine. Okay, it's cleaned out all around, and the surface finish came out very well. I'm happy with it as is. Now this side, I had to remove 1.25 millimeters in order to get it cleaned up here on this edge, because it was semi-bowed, especially down at the bottom. But I managed to clean it up nicely. I was taking full width at 0.25 millimeters depth of cut with the end mill, and with a very low feed rate in order to avoid chatter on this machine. Now I've gone around the edge here with a file, removed all of the burrs on top, and a little bit of dross that was left over from the flame cut process, especially on the places where the chuck jaws is going to touch. So it's ready for the lathe now. Okay, that is my quick and dirty way of centering a piece of plate on a forger. Now, this is not by all 100% accurate means of centering up your stock, but for this application it's close enough. Now, I don't have an attachment for a DTI on my tool post. I still need to make one. So that's a future project, but this works quite well for me. Now, the reason why I'm not using this magnetic base of mine is got some movement on the base itself. So every time I pull on a plunger, I'll get a different reading even on the same surface. So yeah, this works for me. If you don't like it, you can drop a comment. If you find it useful, you can also drop a comment. Okay, I had to take out 29.6 millimeters on the OD. That's across the diameter there. I had to clean up the ball entirely so that I cleared the interrupted cut, because this hole that was in here was very far out of center, and it's got it at almost like a bean shape in it. So it was messing around with my boring bar. You would have seen a lot of flex on it. Luckily now I'm clear and past that, and the bore is now at 55 millimeters, and I need to take it up to 70 to 70.5. That is my target there. So that's another 15 millimeters to go. So I'm not gonna take you through the whole take you through every cut here, so I'll just bring you back on my last finished pass. You would have heard quite a bit of ringing here. Okay, the video is a bit fast forwarded, so that it will create a high pitched sound. But even with a little bit of chatter, it still feels smooth. Now what I've done is I've wrapped a piece of lead solder around the tip of the boring bar in order to absorb some of the resonance, or to cancel the resonance. Now here in the back it squeals extremely, but that is because it's cutting on the burr on the inside. Now when you remove a plate like this, you would be tempted to stick your fingers through and forgetting about the burr in the back, which will cut you in pieces. Okay, I've got a nice fit on it. It's loose. I don't want it too tight because if the tube should expand for some reason, uh, obviously because it's under pressure, I don't want it to get stuck in the plate. So I've got a little bit of clearance there. So now I'm going to use my trusty square insert to do the facing on this end here, because it being an interrupted cut. Any other insert that I'll use will just chip. Need to move my tool post back because this my tool is not clearing the back here. Now I've tested it in a couple of places just to see how flat it is. As you can see here it's cutting, there it's not, and here in the middle it's a little bit bowl shaped on this end. So I'm just want to get more or less a feel for how much I can take off to do a single pass. Right, so I'm going to take a quarter of a millimeter the facing cut here and see how it looks afterwards. Okay, that was a harrowing experience. This thing is chattering like crazy, and there's still a little bit of pitting here. So what I'm going to do is I'm going to advance it a little bit. It looks like even the table got pulled in more, according to my Diaro. So what I'm going to do is going to speed it up and then reverse it out. Now the reason why it's chattering, and I've proved it, you'll see this ring here on the inside is much smoother than here, is my lead nut is worn out again. Now what happens is the table pushes it, the lead screw pushes the table in, and then once the tool starts cutting, it grabs it and pulls it that way, and it clears until it hits the other end of the nut, until the backlash is out. Then it pauses till the lead screw catches up again, and it repeats the process, and this is what you're getting. So what I've done here is I've locked the table. Now if you're worried about my grips, I've got brass tip locking screws, so it doesn't hurt it much, and that stops the table from advancing, and the cut is much better. So yeah, in my near future I'm going to make another lead nut. That is the result that you're looking for. Now this is perfect, nice and smooth. So yeah, a quick tip is to lock your table. If you have too much backlash, if you're getting a rubbish finish, then you know it's either your gips, and I've tightened the gips before I started this process. And if you're still getting chatter, then you know it's because of a worn lead screw or lead nut. So yeah, that's something that I can live with. I just need to break the edge here. The inside edge I'll do with a deburring tool, because the tool is not going to fit in there. Now I've left myself half a millimeter for cleanup here. I wasn't expecting to take so much off, but because of this chatter marks that we're having, it became necessary to take a 0.5 millimeter cleaning cut. And there, scratch my perfect finish. Other side I'll have to do when I turn it around. This plate is all done. I've taken off the edges with a file, back and front, and as you can see, there's some heat affected zones on the steel, which means it's a carbon steel. Even the chips is telling me that it's a carbon steel because it's stringy. If it was a mild steel, it would have given me a rubbish finish, which you usually get from mild steel, as it tears out instead of cutting. Now the curiosity is getting the best of me. I want to see whether my shortcut in centering this the stock, how effective it was. So what I'm going to do is take a measurement here. Get the minimum and zero it. And this is a bit finicky. Let me lay down flat. Maybe I can get you to see as well. So make sure that I get it on an even surface here, not on a chamfer. 0.03 millimeters, that's about 1 thou. Turn it this way around. One thou. So as you can see, that there's many ways to center your stock, and I think this is reasonably close. 1/1000 on a just using a visual cue and a boring bar, and centering with your DRO using the half function is I think it was pretty, even though it's not acceptable in practice, I think it got me very close, and it took less time as well. So yeah, I hope you enjoyed this build. Learn a couple of things, especially with the surface finishes. Reasons why you'll get chatter and stuff. There's so many factors that can cause chatter that it's you have to eliminate it bit by bit. You'll usually start with your spindle, then go to your gips, and then in this case it'll end up being the lead nut. So yeah, I hope you enjoyed it. Until next time, cheers.